So here we have a question, which looks like it's going to be making use of your inscribed rectangles, perhaps, because they've drawn it in for you, and basically might relate to concepts of integration and area and how you build up an integral from what we've discussed. But let's take a look. So you've got the curve y equals 1 over the x plus 1 all squared. There are n rectangles of equal width inscribed, and this is between the values of 0 and 1. This squiggly line over here is just to represent that these rectangles, you don't just have 1, 2, 3, 4, 5 rectangles. You have n of them. They just didn't draw them all out, and the n could be any number for now. It could be 1,000,000 for all you know. So the height of the rectangles is determined by the x value on the right of the rectangle, forming what they call here the lower rectangles. Because it's a strictly decreasing function, that's why if you're going on the right, then it will be lower than, I guess, the actual function, and so it's a lower rectangle. So given this, give the area of the first rectangle on the left. Okay. So when you do questions like this, you just got to think about area of a rectangle. Don't be overwhelmed by what they're asking you. They're just asking you for the first rectangle. Just got to think about how you get a rectangle's area, and that's hopefully not hard. It's just the length times the width. And then you just have to think, okay, I've got the length. That's this distance here. And I've also got the width that I need to work out. That's this here. So one by one, how do I get it? Well, maybe the width may be easier. You know that there are n rectangles of equal width between 0 and 1. So you know that you've got 0 to 1, which has a length of 1. You know there are n rectangles, and they're equal. So it would appear logical that you're just splitting this length of 1 n times, and so the width will just be 1 divided by n. Now, on the other hand, the length is basically the height of the rectangle, is determined by the x value on the right-hand side of the rectangle. So basically, if we can figure out what this x value here is, we'll call that a for now. So if we can figure out a, then it probably makes sense that the height, which is our length, is f of a, because after all, this is the function y equals 1 of fx, which is 1 over x plus 1 all squared. So it should be fairly straightforward once we figure out what the x coordinate is. But I guess we already did figure that out because, well, we said that the width is 1 over n. So if this is 0 and this width is 1 over n, then you're 1 over n across. And this is another 1 over n across. And this is another 1 over n across, and so on. So it would seem to make sense that this is being 1 over n across, that a must equal 1 over n. And f of a is just subbing 1 over n in here. So f of 1 over n would be 1 over n plus 1 all squared. So we could just simplify that a bit. So that would be 1 over n times n plus 1 all squared, which is n squared over n plus 1 all squared. With that in mind, the length, of course, would then be 1 over n times n squared over n plus 1 all squared. So the area of the rectangle on the left would be n over n plus 1 all squared. And that would be your answer to part 1. Part 2 then asks you to find a simplified expression for the area of the kth rectangle from the left, and then to deduce the last part, which probably is where we're going to bring in the other concepts. Okay, so we're now going to basically do this, but for a kth rectangle. And I'll just sort of draw this out. So this is rectangle 1, this is rectangle 2, this is rectangle 3, and you want it for the kth rectangle. Right? Now, it's the same idea. We just basically follow the same idea. So the whole point of part 1 is to try to lead you through it. We're still going to find an area of a rectangle, so we still want the length and width, or if you like, height and width of this rectangle. Now, the width we've already worked out. It's 1 over n, because they're all equal. So that's done. The only thing is we need the height. Now, the height of the kth rectangle is, well, think about it. The first rectangle was based on 1 over n, right? Now, the second rectangle will be 1 over n across and 1 over n across. So this one is going to be based on 2 over n as the x value. And the third one will be based on 3 over n. So if the first one's based on 1 over n, being 1 over n across, and the second one is based on another 1 over n across, bringing it to 2 over n, and the third one's based on another 1 over n across, being 3 over n, it would make sense that the kth one, whatever it is going to be based off this one, which is k over n. So hopefully with that in mind, let's get ourselves a clean board and work that out. So the area of the kth rectangle is going to be the width times the height. Recognizing, of course, that the width is 1 over n, and the height is just going to be f of k over n, as we discussed. Now, what is the function? The function is 1 over x plus 1 all squared. So that means that's 1 over k over n plus 1 all squared. If we just multiply both sides by n squared, that means it's n squared over n plus k all squared. And then, of course, that means your answer is going to be 1 over n times n squared over n plus k all squared, meaning it's n over n plus k all squared. Okay. So that is the area of the rectangle. So now it may be helpful to now again go back to the diagram and look at the expression they want us to prove. They want us to deduce this. Now, keep in mind that we've just worked out the area of a rectangle for a kth rectangle is going to be n over n plus k all squared. Now, deduce that the limit as n approaches infinity of n times 1 over n plus 1 all squared plus 1 over n plus 2 all squared plus dot, 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 plus 1 over 2n all squared is a half. So think about this. Maybe it's more obvious if you multiply the n in. You've got n, forget the limit for now. You've got n over n plus 1 all squared plus n over n plus 2 all squared plus n over n plus 3 all squared plus n over n plus 4 all squared plus dot, 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 plus maybe n over n plus k all squared. That might be helpful. And then your last one, is going to be n over 2n all squared. That one might not be so easy to see in the way it's written. So don't worry about the half. Just think about what this is. Remember our answer to the first one was n over n plus 1 all squared. And remember our answer to the second one was n over n plus k all squared. And all we've done here for now at the bottom is multiply that n in and forget the limit for now. So we've got multiply that, so that's n over n plus 1 all squared. That kind of looks like this. Well, it is that. So that appears to represent the area of rectangle 1. And then here, n over n plus 2 all squared. Well, if you think of this formula, the second rectangle is going to be n over n plus 2 all squared. That's rectangle 2. Here, n over n plus 3 all squared is going to be rectangle 3. N over n plus 4 all squared is going to be rectangle 4, which is not drawn there. N over n plus k all squared is going to be the kth rectangle, which is somewhere in the middle. And so you will probably guess that this is the last rectangle, and of which you have n rectangles. So, and it is. It might not be immediately apparent to you, but if you think about it, 2n is n plus n. So you can think about, if we just rub this out, and now instead of thinking of it as 2n all squared, we think of it as n plus n all squared, for example, then that would represent quite clearly the nth rectangle. So in other words, this whole thing inside the limit just represents the sum of the area of the rectangles. And that's a pretty key point to do this question. So we've recognized that essentially, and you would write this out, but basically that ignoring the limit for now, that what's inside is basically representing the sum of the area of the rectangles. And then the question then you'd have to ask yourself now is, once you've got the area of the rectangles being what's inside the limit, what happens when we actually take the limit as n goes to infinity, which we've ignored for now? So what does that mean? Well, when n goes to infinity, well, what is n? N is the number of rectangles, and each rectangle has a width of 1 over n. So as n goes to infinity, what we're really saying is we have more rectangles, an infinite number of rectangles, in fact. How would you get more rectangles given that you're not sort of going from, you're still going from 0 to 1? Well, I guess you're making them skinnier, right? You're making them less wide. The rectangles become less wide. They become narrower. And so as your rectangles get narrower and narrower and narrower into an infinite, like if you have infinite rectangles, then your rectangle basically will have sort of no width. It will basically go towards 0. So for all intents and purposes, you're just going to get lines. You're not going to get rectangles, you're going to get lines. And so as you can probably see, the skinnier your rectangle, the less sort of gap you're going to have because they're very skinny. So in other words, you can hopefully see, as we discussed when we did integration, as you take an infinite number of rectangles, the limit will actually go towards the exact area. And in fact, that's entirely how how the base of calculus is the limit. And so to get this half, we basically just need to work out the exact area. So with that in mind, with all of that sort of explained, we're basically just now going to write this out. So we would essentially explain that, note that n times 1 over n plus 1 all squared plus 1 over n plus 2 all squared plus dot 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 plus 1 over 2n all squared is n over n plus 1 all squared plus dot 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 plus 1 over n plus n all squared, as we discussed, which is the sum, if you like, of n over n plus k all squared, where k is from 1 to n, which is the sum of the rectangles by part 2. Therefore, the limit as n approaches infinity of this must equal the exact area under the curve from 0 to 1. So let's find that exact area. That exact area you will need to find using integration. So the integral from 0 to 1 of 1 over x plus 1 all squared dx is the integral from 0 to 1 of x plus 1 to the negative 2 dx, which is 1 over n plus 1, x plus 1 to the n plus 1, 1, 0, it's negative 1, a half, minus 0, minus 1, actually. So it's negative half times negative 1, so and therefore the limit as n goes to infinity of the sum from k equals 1 to n of n over n plus k all squared, which is the equivalent of the expression they've got inside, equals a half. And that's basically it. That's how you do questions like these. You pay attention to the sort of area of the rectangles. In this case, they've used what they've called the lower rectangles, which are the inscribed rectangles. There are other questions where you might use the upper rectangles or the circumscribed rectangles, or you might use, both, depending on the question. But in this question, you just needed to do that, recognize the relationship between them, and take the limit, and that's how you do the question.